So we got the motor here. It's a little bit heavy. Maybe one should put gloves on and listen it. What do you think? There. These are fingers. See? Pivot. Oops. Okay, just set it off. And I'll put it on here. That's fine. So, there we got it. Set on that and this pallet. Like that. I don't know really what we want to do here. Maybe we'll put this. Okay. So, what's underneath? Better to lift it 3 times, isn't it? Okay. It's about good there. I think we'll just unpack it. It's really cold outside now, so I'm kind of feeling if this has been outside in the... Okay, the package is open underneath, so we might as well. Thought if it was really cold, I would leave it in the plastic wrapping so you didn't get condensation on it, but when it's only wrapped on top, there's no point in that. Okay, this looks a little bit more new than the other one. 7.5 kilowatts. We just got these here. It's nice. So we can just connect the wire straight in without some kind of weird coupling or connector. It's pretty cold. Looks nice. That will serve us well here. Okay, so we are back at the high pressure coolant system. A lot of things have been built since the last video. I have been quite busy with a lot of things, so I haven't been able to film, or there just wasn't time. I finished the tank, painted it, the 2K epoxy of some kind. I've made this subplate, or painted it. I think you saw that I cut it out. And I changed this subplate. I have the original subplate for the knoll pump. And then I made a new one, and then I had to make another one. So this is the third top plate here. Because of the placement of the arrangement of everything. There's not much space here really, so pump and motor takes up too much space. So anyway, 7.5 kilowatt 3-phase motor. And the knoll pump is underneath there, I'll show you afterwards. The pump outlet, the pressure side, goes up here. It's the pressure regulation valve, so if there is too much back pressure, the rest goes back into the tank. It goes here to the gauge, and this is to the machine. So the return from the sump of the machine goes in here and down in the tank. I'll have a filter before this. So that's the basic layout. Everything mechanical and plumbing wise is finished on the tank. Here's one of the height adjustable feet. And everything is finished, painted. This is the inside of the tank. Here's the pump. And here's the suction side. I couldn't find the coupling that was exactly the way I wanted, so I made it soldered onto here. You saw that, I'm sure. Yeah, like so. And there's the exit from the tank, or the drain. And I started on the electrical cabinet. Here's some of, or most of the components I'm going to use. So we're going to do a temporary layout on this particle board. I'll try to do a little layout there. Like so. About like so. I'll try to explain this when I have put all the components in place. I guess we need a little more room here. So, I will put this on the thin rail yet, but we'll do that. These cable channels are too long. Don't cut them. So, we have a few things we need to control. It's the main pump motor, and the motor for the pump in the sump, and the float valves. I think that's it. We'll have 3 float valves. So we have incoming power. Yeah, we'll have a switch, main switch first on the outside of the cabinet. Put this together, but anyway. We have the circuit breakers, one for the main pump, the sump pump, and for the 24-volt supply. There's to make 24 volts DC for the control circuit. And we have the contactor for the main pump, and this is the contactor for the second pump, and this I have laying around, so we'll use this for the 24-volt control circuit. It's a contactor, but I could have used a relay, but it's cheaper to use a contactor when you have one. Here's the motor protection for the main pump, or main motor, and a soft starter. So that's basically everything that's going into the cabinet, except for the wiring. The main pump will be controlled or started and stopped from the machine, which will trigger this contactor, which in turn will trigger this contactor. And in that circuit with that one, that's a 24-volt circuit, there will also be a float switch in the sump. So if the sump overflows, the main pump will stop. And the sump pump will be controlled by an upper and a lower float. So it will start when a coolant level reaches the top and stop when it reaches the bottom. And that's basically it for that one. So I will try some wiring. We'll get you back for that, hopefully.